Welcome back again to Advanced Functions MHF4U 1. This is Exponential and Logarithmic Functions chapter. In this lesson number 5, we're going to learn about how to solve exponential equation in one variable using a variety of strategies. First, let's go over what is one-to-one function. So in order to solve any exponential variable, you have to make sure that the base is exactly the same from the left side to the right side. So as you can see, a and a, it's same. So if the base is same, then you could equate the exponent and then solve for the variable. Keep in mind that the base has to be greater than 0 and it cannot be 1, and x and y could be any real number. Question 1. So let's try solving a variable that is in the exponent. First step, notice how the base is exactly the same left to right. Therefore, we're going to equate the exponents. 2x minus 1 equals 5x plus 3. Then we're going to collect the like terms. So I'm going to move 2x, so it's going to be negative 1 minus 3, 5x minus 2x, negative 4 equals 3x, x is equal to negative 4 over 3. So when x is negative 4 over 3, on the left side and right side, I'm going to get the same answer. Letter B. Now, you will notice that the base is not the same. We have 5 here as a base and 125. So what you can do is find the bigger number and see if you could equate to the same base on the left side. So first, I could do 4x minus 1 equals 125 is actually 5 to the 3. But keep in mind, when you have this, you could turn that exponent into negative exponent with the same base. So 4x minus 1 equals 5 to the negative 3. Then you could equate the exponent now because the base is now the same, 5. Okay, then 4x minus 1 equals negative 3. 4x equals negative 3 plus 1. 4x equals negative 2. So x is equal to negative 1 over 2. And we just solved for x. Next. Now notice how we don't have a same base at all. So it's like we have 36, 2x plus 4. And we have 1296x to 1 over 2. So we don't like radical. So first thing is change the radical into exponent. And I could do the distributive property here, power of power. So you multiply 1296, 1 over 2x. The next question is, what is a same base that could turn into 36 and 1296? Now, so in this case, so you will do a try and error, and I noticed after calculation, the base will be 6. 6 to the power of 2 gives me 36, and 6 to a power of 4 gives me 1296. So try to use your calculator to do try and error to make the same common base. After I make a same base, I'm going to do the power of power law where you are going to do the distributive property here, multiply. So it's 6, 4x plus 8 equals 6, 4 times it will be 2x. Now that the base is same, I could equate it. 4x plus 8 equals 2x. So 2x is equal to negative 8. X is equal to negative 4. Okay, now for letter B here, or letter D actually, letter D, is, so I just see like different terms. So first, I will collect the like terms. So I have negative 8 and 1, 0, 6. So I'm going to move negative to the other side. So 4, 3x minus 1 equals, it's going to be positive 8. So it's 1, 0, 2, 4. Now that I collected like terms, now we have base 4. So I'm going to see if I could change 1024 into base of 4. But unfortunately, it doesn't work. You're going to get decimal. So then you're going to keep going down. So move, what about a base of 2? Because it's an even number, the next runner down will be 2. So 2 to the 2 is 4. And using your calculator, you will notice that 2 to the 10 would give me 1024. So now we are going to multiply the power of power. So 6x minus 2 is equal to 2 to the 10. Now that the base is same, we could equate the exponent. So 6x minus 2 equals 10. Collect the like term. 6x equals 12. X is equal to 2. And that will be my final answer. Now, okay, letter E. Now this is a little bit different now. So we have coefficient here. It seems like this is the base, right? Because the exponent is attached to the base always. So I'm going to divide 736 to the other side. So move it to the other side. So it's going to be 3 divided by 768. It's a number, it's a constant. 1 over 2 x 1916. So I could simplify this. So it becomes 1 over 256 equals 1 over 2 x to the 1916. Okay, now I can change 256 as a base of 2. So if you do it, it's 2 to the 8. So I could say 2 to the 8. So I'm going to put it in here. You could put it this way, or you could put 1 over 2 to the 8. It's same thing, because 1 to the 8 is 1. Equals 1 over 2 x over 1916. Okay, so now that the base is same, which is half, I'm going to equate the exponents. So 8 is equal to 1 over 1916. So I'm going to move 1916 times 8. So x is equal to 15,328. And that will be my answer. So rule of thumb is that if you're given a number other than a base that's attached to the exponent, then always try to collect the like terms by either dividing, multiplying, or adding or subtracting. Okay, so next we have log. So we don't like radical. Again, I'm going to change the radical into exponent form. So it's 1 over 1000 to the power of 1 over 6. And then we could, so if you punch it in your calculator, 1000 over 6, then I would be doing equals log, it's 1 over, you're going to get 10 to the 3 over 6. Okay, the reason why it's 3 over 6 is because 1000 is equal to 10 to the 3. There's 3 zeros. So therefore, I simplify 1,000 into 10 to the 3 to power of 1 over 6. And then I multiplied and I got this. Okay, and then you can do log. Now so if I simplify, 3 over 6 is 1 over 2. So it's going to be 10. I'm going to flip it, so it's become negative 1 over 2. Okay, so the reason I'm doing this is because the exponent negative, right? So I could flip it and it becomes negative. And to simplify this, remember there's invisible, the base 10. So it's 10 to the 10 x is equal to 10 to the negative 1 over 2. Or you will notice that because we have a same base, x is equal to negative 1 over 2. Okay. Another way you could look at it is, remember this way, log, we have a base of a to a same base of a, n. This is equal to n. That's why you could go to this step right away. Question 2, so we're solving. Now 4x is equal to 17. And you will notice that unfortunately 17, you can't make it as a base of 4. It's an odd number with an even number. So if you cannot make it as the same base, then you're going to take the logarithm to the both sides. So I'll be taking log 4x is equal to log 17. So now that we equated by taking the log to the both sides, because you cannot change it into same base, then we are going to move x to the front. So x log 4 is equal to log 17. Then I'm going to divide both sides by log 4. Isolate for x. So log 17 over log 4. In this case, you're going to use a calculator. Log 17 divided by log 4. X is equal to approximately 2.04. Okay. Next. Okay, so we have 3x squared. So I'm going to distribute to my coefficient and the variable. Don't forget the two of them. So it's going to be 9x squared equals 14. Again, you will notice that 9 and 14, I can't make it the same base. So what I could do is, well, this is actually simple. You don't have to use logarithm. This is because I don't have a variable in the exponent. So you could just square root. So x squared equals 14 over 9. Okay, I isolate it for x. And then square root both sides. So x is equal to square root of 14 over 3. And that will be my final answer. So this was easy. We can use order of operation. The reason because is that we don't have variable in the exponent. But on the other hand, for the letter A, we have a variable in the exponent. So therefore, you will have to take logarithm on both sides. Okay, now, so let's do some more problems. So after 10 days, a bacteria colony has grown from 12,000 to 1,300,000 bacteria. So how long does the colony take to double? Okay, so for doubling question, so first let's write down the exponential. Y is equal to ABX. This is the exponential growth. Now y, let's write it down. So Y is the final amount. A is the initial amount. B is the growth rate. And X is the number of time interval. Okay, so you would have to remember this for any type of word problems. So here we're given so initial and final. So first we have to say let's say D be the number of days in total. The reason why is the question is how long, right? In terms of days. So how long? So that should always be your let statement. And then let's fill in the equation. So we know Y. The final amount we want to have is 130,000 equals A. We know the initial amount. We're starting with 12,000 bacteria. Now, how is it multiplying the growth rate? It's doubling. So the doubling growth rate is a base of 2. And then the X is a time interval. So in this case, X, we have to be careful. X in this case is T is equal to doubling rate. So T in this case is the given time. And D is the doubling period. So for example, is it doubling every 2 hours? Is it 4 hours? So we are given 10 days. So T is 10, but we're looking for the doubling period. Okay, so this will be D. Okay. Now, so first I'm going to move 12,000 to the other side. So I'm going to divide it. So it's 130,000 over 12,000 equals 210 over D. Then I simplify, I get 65 over 6, 2 to the 10 G. Now, because 65 over 6, it's a decimal. So therefore, it's really, you can't equate it to a base of 2. So if you can't do that, you're going to take the logarithm both sides. So log 65 over 6 equals log 2 to the 10 over D. So I'm taking the log. Now we can move this exponent to the front. So log 65 over 6 is equal to 10 over D times log 2. Then I'm going to bring log 2 to the other side, so we're going to divide it. So log 65 over 6 divided by log 2 is equal to 10 over D. So therefore, what we could do is we're going to simplify this. Okay, use your calculator. Then I get about 3.4437. Now, I'm just writing the rounded answer, but when you're doing it, make sure you carry all the digits. And then to isolate for D, D is equal to 10 divided by 3.437. Okay, so I'm rearranging. So D is equal to 2.909. So 2.91 days. So in this case, you can't really have a decimal days. So therefore, my final answer is going to be approximately 3 days. Approximately. So approximately 3 days to double the bacteria after 10 days. Question 4. So an initial investment of $800 will earn 8% compounded quarterly. So compounded means that you're getting interest based on the interest that you're already getting. And how long will it take for the investment to grow to 3,000? Now, for any type of investment question, this is the formula that we will be using. This is also based from Exponential. Y is equal to ABX. Okay, so A, as you can see, is the final amount. P stands for the principal amount, which is the initial. Now, I stands for the interest rate divided by the compounding period. Okay, and then N is a number of times, so given time, times the compounding period. Okay, so this is something that you have to remember for any type of investment with interest question. Now, so let's fill in the information. So we're given final amount. We want the final amount to grow to 3,000. So 3,000 equals, we're starting from $800. So 800, 1 plus, now the interest rate is 8%. So always change it into decimal first. So 8% is 0.08. So 0.08, but we have to divide it by compounding period. Compounding period is quarterly, which is 4, divided by 4. And then N is time, so N times, we don't know because the question is how long. So we could say let N be the number of years. So the time is usually it's in years. So N times, what's the compounding period, is 4. So let's simplify this. So it's 3,000 equals 800. So if I do 0.02, so it's 1.02 over to power of 4n. Okay, now I'm going to move 800 to the other side. So it's going to be 3.75 equals 1.02 to 4n. Now, again, we're given decimal, so it's really hard to equate with the same number. So what you're going to do is you're going to take the logarithm both sides. Log 3.75 left side. So you got to do it to the right side. Log 1.02 to the power of 4n. Now, I'm going to bring exponent to the front. So log 3.75 equals 4n times log to 1.02. So I'm going to bring log 1.02 to the other side, isolate for n, and then we're also going to divide it by 4. So it's log 3.75 divided by log 1.02 equals 4n. But I could divide it by 4 to the both sides, so it's 4 here. So therefore, punch it in your calculator. N is about 16.68. So therefore, you could say, therefore, how long will it take? The investment will take about, you could say, 17 years. Okay, approximately. Okay. But this will be the final answer, 16.68.